All right, here we go on the last chapter of the last unit for this course. So good job getting through this. Let's go ahead and get started. Hopefully you've already been through your vocabulary. You will need it. A lot of the terms, most of the terms for this particular lesson. And example 1 says a car is traveling on an asphalt road with a drag factor of 0.78. Again, that would be a vocabulary word hopefully you're familiar with. The speed limit on this portion of the road is 35 miles per hour. The driver just had his car in the shop and his mechanic informed him that the brakes were operating at 100% efficiency. The driver must make an emergency stop when he sees an obstruction in the road ahead of him. His car leaves 4 distinct skid marks, each 80 feet in length. What is the minimum speed the car was traveling, round to the nearest tenth, and was the driver exceeding the speed limit? So in order to do this, we have a new formula, and it's called our skid speed formula. And let's take a second to go through that. The formula looks a little like this. The speed is the square root of 30 times the skid distance times the drag factor times the brake efficiency as a decimal. So let's break that down. S equals speed of the car. D equals the skid distance. F is my drag factor. Oh, I forgot drag. Let me go back. So F is, again, drag factor. N is brake efficiency as a decimal. So let's see what we have here, plug our values in and see what we get for an answer. So I'm going to, as I did with many other lessons, I identify my variables on the side so that I can plug in my values and solve. The speed is what I'm looking for. That was the first question. So let's do this in a little different color here. The drag factor, or I'm sorry, the skid distance. It says here that there were 4 distinct skid marks, all of them being the same, which makes our life a little bit easier. So D is 80. The drag factor was 0.78. And the brake efficiency as a decimal, remember 100%. Move the decimal over twice. I'm looking at 1 for N. Plugging that into my formula, I've got 30 times 80 times 0.78 times 1, and it's the square root of all of those values. All right, let's go ahead and plug this into our calculator then. We're going to plug in our values first, and then we're going to take the square root of it with this calculator. So we've got 30 times 80 times 0.78 times 1, and then the square root of that, we can see here that we're looking at 43.3 miles per hour. And so that was the minimum speed that the car was traveling when they entered into the skid. And the second question says, were they speeding? Well, the speed limit is 35 miles per hour, and they were going greater than that, so the answer is yes. The car was speeding. All right, please press pause, solve this, come back when you're ready. All right, let's look at this. First, I'm going to identify my values. I've got my skid distance, my drag factor, and my brake efficiency. It says the drag factor was X. I'm going to actually change colors here to identify the difference. The braking efficiency was Y. And it leaves 4 distinct skid marks of z. So what was the speed? So plugging this in, there's only one little kind of tricky part here to remember. So we've got 30 times the skid distance, which was z, times the drag factor, which was x, times the brake efficiency, but remember it's as a decimal, so it's going to be y divided by 100. Did you catch that one? Example 2. It says Melissa here was traveling at 50 miles per hour on a concrete road with a drag factor of 1.2. Her brakes were operating at 90% efficiency. To the nearest tenth of a foot, what would you expect the average skid marks to be? So here it's giving us a little bit different information and asking us to solve. It gives us the speed. The speed was 50 miles per hour. It gives us that it was a drag factor of 1.2 and brake efficiency of 0.9 or 0.90 for 90%. And what we're looking for is the drag factor. The skid distance. So plugging that in, I've got 50 equals the square root of 30 times d times, let me make that look a little bit more like a d so it's not confusing. So times d times 1.2 and times 0.9. Now when I multiply those values together, I get 50 equals 32.4 d all in the square root. Now the question here is, how do I get rid of that square root? Well, the fastest way to get rid of a square root is to square it. But remember, in algebra, if you do something to one side, you have to do it to the other. So you're going to square both sides. Because the trick here is that a square cancels out a square root, and I end up with 2,500, which was 50 squared, equals 32.4 d. I divide both sides by 32.4, and I find that the average skid distance for this particular problem was 77.2 feet. All right, please press pause, solve this, come back when you're ready. All right, let's see how we did. Let's first identify over here, we've got our speed, our skid distance, our drag factor, and our brake efficiency. And it says Neil is traveling on a road at m miles per hour. So there's my speed. He slams his foot on the brake pedal in order to avoid hitting a car up ahead. He's traveling on a gravel road with a drag factor of A, and his brakes are operating at 100% efficiency. His car leaves 3 skid marks in length, which is x plus y plus z divided by 3. And we'll go through and I'll explain that in just a second. Whenever we have 3 different skid distances, we have to take the average of the skid distance, which is also called the mean, which means I add all the values together and I divide by how many there were. Because there were 3 skids, I'm adding them together and dividing by 3. So plugging into the formula, I've got m equals the square root of 30 times x plus y plus z divided by 3, extend this out a little bit, times a times 1. The next thing I have here is m equals, and we've just got 30a times x plus y plus z divided by 3. Then it was the square root of it. So remember, the quickest way to get rid of the square root is to square it. So now I have m squared equals 30a times x plus y plus z, all divided by 3. And to actually then solve this, I'm going to take that and divide both sides of it. So my final answer, I end up with the speed squared is 30a divided by x plus y plus z divided by 3. And that will give me my skid distance. All right, example 3. It says an accident reconstructionist took from the yaw marks, that's a little new term, but it was in our vocabulary. Using a 43-foot cord, she determined that the middle ordinate is approximately 4 feet. The drag factor was 0.8, determined the radius of the curve to the nearest foot, and then how fast the speed was going. So here we have two formulas to deal with. Our second formula that we're going to use is when using our cord and our yaw mark and using the radius, and it is 15, square root of 15 times the drag factor times the radius. But first we have to find the radius, and in order to find the radius, that is the cord squared divided by 8m plus the middle ordinate, which is m, divided by 2. So we know that the cord equals 43, and we know that the middle ordinate equals 4. So plugging that in, I've got 43 squared divided by 8 times 4 plus 4 divided by 2. When I do all of the math, I end up with 57.78 plus 2, which gives me 59.78 for the radius. Now I'm going to use that second formula, and I'm going to plug it in. So I've got that the speed equals the square root of 15 times the drag factor, which was 0.8, times 59.78. So let's go ahead and plug that into our calculator. Clear out that value. We've got 15 times 0.8 times 59.78, and the square root shows that they were going 26.8 miles per hour. All right, last you-do of the entire course, and I'll give you a second and then come back and we'll go ahead and solve. All right, identifying here, we know that our cord, it says, is 62.4 feet, and the middle ordinate is 5. So using our formula, we know that we have 62.4 squared divided by 8 times 5 plus 5 divided by 2. When I multiply all of that out, I get, we'll plug this into our calculator here real quick. So we've got 62.4 squared divided by 8 times 5 is 40, so we get 97.344, plus 5 divided by 2, which is 2.5, so we get 99.844. So my radius equals 99.844. Now plugging that into our formula, we know our speed is the square root of 15 times the drag factor, which was 1.2, times the 99.844. So plugging that into the calculator, we end up with the speed is approximately 42.4 miles per hour. Great job on the course. Hope you do well. Contact me if you need any help getting ready for the final.